Have you ever wondered how a television or radio signal travels from a broadcasting station all the way to your satellite decoder at home? It may seem like magic, but it is actually a carefully coordinated process involving broadcasting centers, powerful earth stations, communication satellites, and the equipment installed on your house. In this video, I'll explain the entire journey in a simple and easy-to-understand way. Every satellite television broadcast begins at a television or radio station. This is where programs such as news, sports, movies, documentaries, and live events are produced. The raw video and audio created in the studio are far too large to be transmitted directly to millions of viewers. Therefore, the content is first sent to a broadcast center, where specialized equipment converts the analog or raw digital signals into a standard digital format. The video and audio are then compressed using advanced compression technologies such as MPEG-4 or HEVC. Compression reduces the amount of data required without significantly affecting picture and sound quality. Multiple television and radio channels are then combined into a single digital stream, a process known as multiplexing. If the service is subscription-based like DStv or SLTV, the channels are also encrypted to prevent unauthorized viewing. Once the signal has been prepared, it is sent to an uplink earth station. An uplink earth station is a highly specialized broadcasting facility equipped with massive satellite dishes, some measuring more than 10 meters in diameter. Unlike the small satellite dishes installed on our homes, these giant antennas are powerful enough to transmit signals over a distance of approximately 35,786 kilometers into space. This transmission from the Earth station to the satellite is called the uplink. High above the Earth's equator, in what is known as the geostationary orbit, communication satellites continuously receive these uplink signals. A geostationary satellite revolves around the Earth at exactly the same speed as the Earth's rotation, making it appear stationary from our perspective on the ground. This fixed position allows satellite dishes to point permanently at one location in the sky without constantly tracking the satellite. Inside the satellite are electronic devices known as transponders. These transponders perform four important tasks. First, they receive the weak uplink signal from the Earth station. Second, they amplify the signal to restore its strength. Third, they shift the signal to a different frequency to prevent interference between incoming and outgoing transmissions. Finally, they retransmit the signal back toward the Earth, covering entire countries or even continents. This transmission from the satellite back to Earth is known as the downlink. When the downlink signal reaches your home, your satellite dish acts like a giant reflector, collecting the weak microwave signals arriving from space. The dish focuses these signals onto the LNB, or low noise block converter, mounted at the end of the feed arm. The LNB is one of the most important components of a satellite receiving system. It amplifies the extremely weak satellite signal, filters out unwanted noise, and converts the high-frequency microwave signal into a much lower frequency called the L-band. This lower frequency signal can travel through a standard coaxial cable with minimal signal loss. The signal then travels through the coaxial cable into your satellite decoder. The decoder is essentially a specialized computer designed to process satellite broadcasts. It tunes to the selected channel's frequency, demodulates the digital signal, decrypts encrypted channels using the subscriber's authorization, and decompresses the video and audio data. Finally, the decoder converts everything into a format your television can display, producing the pictures and sound you enjoy every day. Many people often ask why television stations don't simply transmit directly to the satellite themselves. The reason is that building and operating an uplink Earth station is extremely expensive. It requires powerful transmitters, sophisticated signal processing equipment, highly trained engineers, and very large satellite antennas. Instead, most television and radio stations send their programs to a central broadcast facility or teleport, where many channels are processed and transmitted together through a single uplink station. To summarize, the journey of a satellite television signal follows a clear path. It begins at the television or radio station, moves to the broadcast center for encoding and compression, continues to the uplink Earth station, travels into space to the communication satellite, returns to Earth as a downlink signal, is collected by your satellite dish in LNB, passes through the coaxial cable to your satellite decoder, and finally appears as pictures and sound on your television screen. Understanding this signal path is the foundation of satellite television technology. Once you understand how the signal travels, it becomes much easier to learn satellite dish alignment, signal troubleshooting, frequency settings, LNB operation, and decoder configuration. In the next video, we'll explore another important aspect of satellite television technology and continue building your knowledge step by step.